Hello, welcome to the linear algebra class. You are taking this course, and why is it important? Well, it has many applications in the fields of computer science, engineering, physics, economics, and of course mathematics. And the first chapter, which is about linear equations, so the chapter is linear equations and linear algebra. Why do we need to learn to solve linear equations or systems of linear equations? Because many real world problems actually boil down to solving a system of linear equations. So what is a linear equation? Well, we say a linear equation in n variables. X, let's say the variables are x1, x2, x3 up to xn, and it's given by a1x1 plus a2x2 plus a3x3 plus dot dot dot, means you can continue like that, plus a sub n x sub n equals a number b. And here all these a1, a2, a3 up to so on, which are the coefficients, and the number b on the other side, these are all real or complex numbers. Now recall, a linear equation in two variable will be something like 2x plus 3y equals 7. And real equation, linear equation in three variables like x minus 3y plus z equals 1. Now if I have x plus 2z equals 3, this is also a linear equation in three variables. Now here are examples of, but now instead of x, y, z, we are going to use these x1, x2, x3 up to so on, because these are can be used for given a larger number of variables. So here is an example of actually two examples of linear equations, and so these are both linear. You can simplify and get it in this form, and this becomes that, which are both linear. You can compare them to the linear form given here. Now I show you two examples of equations which are not linear. So on the left hand side you see 4x1 minus 5x2, which is similar to the linear equation, but on the right hand side we have x1 times x2, means two variables are being multiplied, therefore this is not linear. So why is this a linear equation? And the reason is that the exponent on each of the variables is 1. So when we come here, this will give us different situation. So we won't have exponent to be 1. And here we have this x1 is being square rooted, the exponent on that variable is half, which is, that's why it's not linear. So what is a system of linear equations? And when we have the system, sometimes we call it just linear system. So it is a collection of one or more linear equations in the same variables. So for example, if we have these two equations, 2x1 minus x2 plus 1.5 x3, which we could also have written as 3 over 2x3 equals 8. And the second equation is x1 minus 4x3 is equal to negative 7. Now a solution of a system is a value that satisfies each equation in the system. Actually what will happen, the solution will be of the type like S1, S2, S3 in this case, and in the general case it will be S1, S2, S3, so on, Sn, and then parentheses. What are these? These are the S1, S2, S3, so on. These are the values of the variable x1, x2, x3 that we will get once we solve the system. So then what we do, we put them in parentheses like this, and this is called a tuple. So this is an untuple, and this is a 3 tuple. So we together, we take these S1, S2, S3 and we plug in these two equations, and if it is a solution, then it must satisfy the equations. Now if we have more than one solution, a set of all possible solutions of a linear system is called the solution set. Now, two linear systems, so two systems of linear equations or two linear systems are called equivalent if they have the same solution set. So if we have two different looking linear systems, but if we solve them, we have the same answer or solution, then we say the systems are equivalent. Now, this is something you have to note, that a system of linear equations can only have the situation that there is no solution, there is exactly one solution, and then third choice is that infinitely many solutions. And why am I saying this? Because if you recall, system of two equations, in a system of two equations in two variables, so it will be straight lines. What is the possibility there? We can have a line intersecting another line. So we have exactly one solution, your unique solution or exactly one solution. Then we could have a situation where we have parallel lines, so they will never intersect, never cross each other. So we have no solution. And then we could have the situation that we have a line, and then the other line sits on top of this line. So then in this case we say infinitely many solutions. So what we now do, we extend this idea, and we can see this visually in some, you can check this on your computers with three equations, three linear equations in three variables. So we can say that this is true for any number of equations in any number of variables. Now, a system of linear equations is said to be consistent if it has either one solution or infinitely many solutions. If there is a solution, one or infinitely many, then the system is consistent, and it will be inconsistent if there is no solution. Now, you might have done problems in high school where you solve a set of simultaneous linear equations, and you recall that you can do it algebraically by substitution method or by elimination method. Now here we are going to learn a new method, which is basically a kind of elimination method, and we are going to use matrices in there. So now we will see how we can write or convert our equations into a matrix. What is a matrix? A matrix is a rectangular array of numbers, and the information of a linear system can be recorded in a matrix. For example, given the system, so we have the system of equations here, three equations and three variables. So we have x1. So what is the coefficient there? 1. So we have 1x1 minus 2x2 plus x3 is equal to 0. So what is the coefficient of x3? 1. What is the coefficient of x2? Negative 2. Because I can always say plus, and then I can put the negative sign with the 2. So what we do now, we will write a matrix. If you see here, first row is the coefficients of the variables. So 1 is the coefficient of x1, negative 2 is the coefficient of x2, and then again 1 is the coefficient of x3. So we have a situation. Now second equation is 2x2 minus 8x3 is equal to 8. So the coefficient of x2 is 2, coefficient of x3 is negative 8. So I have 2 and negative 8. What about the coefficient of x1? Well, since x1 is not here, we can always multiply it by 0 and say 0 times x1 plus. So the coefficient of x1 here is 0. So any missing term, the coefficient is 0. Now coming to the third line, a third equation, 5x1 minus 5x3. So now x2 is missing. It means the coefficient of x2 is 0. 5, 0, negative 5. This is the coefficient matrix or matrix of coefficients. And then we have what we do, there is, if you notice, this is same, first three columns are similar, so we append or augment the column which consists of these values on the other side of the equal to sign for each equation, 0, 8, 10. So I have 0, 8, 10 here. This is called the augmented matrix of the system. Now the size of the matrix is given by m by n. So m is the number of rows and n is the number of columns. So this augmented matrix is of size 3 by 4. So that's how we write the size. Now, so I showed you how to get the augmented matrix from the system of equations. Now you should be able to go backwards. For example, if you are given an augmented matrix, let's say 1, 2, 0, 3, 1, 0. So let's make it 5. So these are, so what is this? This is 2 by 3. So the last column is going to be your numbers on the right side of the equality sign. And so notice here, how did we pick these? What were these? These were the coefficients of the first column, gives us the coefficient of the, I should go to the augmented matrix. So first column is the coefficients of the first variable, which is x1. You can write it on the top or you can write it at the bottom. The second column gives us the coefficients of x2. Third column gives us coefficients of x3, and the last is the numbers which are going to be on the other side of the equality sign. So here we have a 2 by 3, so it means we have a system of two equations in two variables. So I have x1, x2. So I can write my equation back, x1 plus 2x2 equals 0, and 3x1 plus x2 equals 5. So you should also know how to go back. Okay, so next is elementary row operations. What are the elementary row operations we can do? So there are 3 of them, and only these 3. We cannot make up our own operations. So first one is that interchange two rows or equation. Now I am writing it for both rows and the matrix and the equation, because matrix, what we do to the equations, we can do the same things to the matrix, or what we do to the matrix, we can do the same thing to the equations. So the first one is, we say, is that we can interchange or we can swap. Swap or interchange. And what does that mean? You can interchange two rows or two equations. For example, these equations here, if for some reason I can swap equation 1 and 3, or I can swap equation 1 and 2, or 2 and 3, whichever needed. So we will see an example how do we do that. Just in a minute. Okay, the second thing we can do is multiply an equation or a row of a matrix by a non-zero constant. So you can multiply the equation or the matrix, whichever you are using, by a non-zero constant. So it could be a negative number, it could be a positive number, it could be any fraction, anything. You can multiply the whole equation or the whole row of the matrix. So remember, these are the rows. So we denote this one, the first one, by R1, big uppercase R1, uppercase R2, and uppercase R3. So third is replacement. So what we can do is replace any row or any equation by the sum of itself and a multiple of another row or equation. So what does that mean? Again, we will see in a minute. Now note here, the row operations are reversible. So if you multiply a row by something, by 3 for example, you can always reverse it by multiplying that row by 1 over 3. And same thing can happen with other operations. Okay, so here is an example. It says perform the elementary row operation on the system. So here is the system of equation. We have 3 of them. This is the same example as I have up there. So the first is interchange equations 1 and 3. So I'm going to show you how do we write it in equation form and how do we write it in matrix form. I already have the original ones here. So this is the original one. So what will happen when we interchange equations 1 and 3? So the equation 3 will come up in place of 1. Equation 2 will stay there as there it is. Nothing happened to equation 2. And then the equation 1 will come at the bottom, will take the place of the third equation. So if we were doing it using the matrix, then here is the matrix. So how it will change in the matrix form. So this is how we write the matrix. By the way, we use these square brackets, big square brackets. Okay, the last row, third row will become the first row. Second row will stay as it is. And the first row will go in place of the third row. And we write something like this. So this swap, we denote it by R1 double arrow R3. So in between here, we will put a line and we'll write that on there. This is a very important thing. So the second process that or operation that we could do was multiply the equation by the number or scaling. So here the question is asking you to multiply equation 2 by 1/2. So what will happen? How will it change? You see, we are doing equation 2. So equation 1 and equation 3 will remain as they are. I can write x1 minus 2x2 plus x3 equal to 0. And the last one is the same. So the ones that are not changing, I will write them. Now look at what. So when I multiply by 1/2, what is going to happen? Well, we don't have anything for x1, so that place remains empty. So that when I divide by 2, I get x2 minus 4x3 equals 4. In the matrix notation, it becomes, I will put an arrow, and this is what I am going to do. And now I will write my matrix over here. Again, the first and the last row remain as they are. And the second row becomes 0, 1, -4, and 4. Then multiply equation 1 by -5 and add in equation 3. So we are going to multiply equation 1 by -5 and we'll add in equation 3. So this is equation 1, this is equation 3. And in the same way, we will do the same. In other words, we will do this through the matrix. Multiply the first row by -5. So I say -5 R1, and I'm going to add this into R3. This is how you will write on the between the matrices the operation you are applying to the matrix. And it is very important how you write this thing, because notice here, you cannot do this. Someone might do this. They multiply the first row by 5 and they multiply the second, and they do this. If you do this, multiply first row by 5 and subtract the third row from there. Well, remember, we didn't see any subtraction there up there, only three possible operations. So no subtraction. Now subtraction means actually what, remember, subtraction is nothing but addition. Subtraction means you actually did this. You actually multiplied R3 by -1, and you multiplied R1 by 5, and then you are adding. This is something you were doing in high school. Here you are not allowed to do that, because you are not supposed to multiply both rows or two equations with different numbers and then add them. You are not allowed that. So we are only allowed to multiply one of the equations or one of the rows by a multiple, by a scalar, and then add it to another row. And what will happen? Which row will change? Well, we are multiplying the first row by -5, or the first equation by -5, but we are not going to write it over here as -5x1 plus 10x2 and so on. Okay? This first row is not changing. The operation of multiplying equation 1 by -5 and adding in equation 3 is going to change equation 3. So we'll keep our first equation as it is. Second equation as it is. What happens to the third equation? So now you can you can do it in your head if you want, but if you cannot, then you can go on a side and do it. Now you can multiply this 5x1 minus, sorry, -5x1 plus 10x2 minus 5x3 equals 0. This is not enough space. I think I will go down here. This is aside from the work we are doing. We multiply the first row, 5x1 plus 10x2 minus 5x3 equals minus 50. Sorry, multiply the wrong row. Okay, we do it again. First row, we have to multiply the first row by -5. So -5x1 plus 2x2 minus 5x3 equals 0. I'm going to add row 3. When I add, this gives me 0. This gives me 2x2 minus 10x3 equals, so this was 10. So now I can write my third equation. So no first term. Start with 10x2 minus 10x3 equals 10. Then the matrix notation, I'll keep my first row as it is, second row as it is, and the last row becomes 0, 10, -10, and then. Now note here that it is so easy to work with these matrices, because we don't have to worry about writing those variables over and over again. So next video, I will show you how to use the augmented matrix and find the solution of the system.